There we go. Hey, welcome everybody once again to Astronomy Daily Live. It's 2 hours UTC, and we're here again, gathering this great group of friends from all over the world to talk astronomy and space and science and all things nerd. Now, for me, this is super easy and super fun, because I've actually been doing this kind of thing for years and years and years and years and years. So where I am in southern Arizona, it is always Mountain Standard Time here, which means I'm always 7 hours behind UTC. So right now it's 2:01 UTC on the 16th of April 2019, but where I'm sitting, it's actually 7:01 p.m. On the 15th of April. And so, coming to the end of the day, been working all day. I've had a nice dinner, and for years and years and years now, every single evening, I sit right here and I look at astronomical papers and I just relax, right? I mean, I'm not really working. That's for, parts of the day, you know, um, mornings, afternoons, that kind of thing. Evenings, I like to chill and I like to look at astronomical things of all kinds. So doing this live stream is exactly what I've been doing for years and years and years. The only difference, really, is me talking out loud, right? I'm really a pretty quiet guy. I like to have discussions. I like to talk all that. But when there's a group, I'll usually just listen, make contributions from time to time, and just enjoy things that way. So the only difference here is that I'm just sort of uh, 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 saying out loud my thoughts, that I would just naturally have anyway. Besides that, sitting in front of a camera, that's no big deal. That's easy. Um, so yeah, I just sort of decided, to take you along, and this allows me to share my passion. The one thing that I love doing more than anything else is giving things away. I love to give. I love to receive too. I love to receive, but I like to give, and I sort of purposely don't have a lot of stuff, and from the background here, you may um, um, not really believe that, but um, with stuff, this is pretty much it. It's, but what I do have is a passion for science and space and astronomy and all that. So I love to give it away. I love to share it. So that's why I am here. So I'm going to pop up the chat really quick, and I'm going to finish my babbling for now and say howdy to Bobby. Hey, what's going on over there?
Ooh-wee, yeah, looking good here. And I just want to let you know that since yesterday I have been doing a pretty darn good job of doing my radio captures and uploading them on YouTube. I did like about a few BHF, and as of today, I just did about a few HF videos.
That's fantastic. So you've got an antenna what kind of antenna do you have? Do you have it outside?
I have
What's your
it
setup?
outside. I got a long wire for my HF and a telescopic link for BHF UHF.
Cool. Very, very cool. And then you're plugging that to your.
I use my software defined receivers.
Cool. Now, are you using a dongle or are you using an actual box?
I'm using the box, the SDR Play RSP1.
Nice.
And come to think of it, just as speaking of radios, how are you enjoying your RSP2 Pro?
So far, so good. You know, there was a little bit of a learning curve in terms of the software interface. I'm using Uno, but I love it. I love it. So
Okay.
yeah.
Now,
Yeah,
are there
like
any digital voice repeaters like Fusion, DMR?
Oh, I have absolutely no idea yet. Yeah, I'm just getting into it.
Because on one of my videos, I locked onto a Fusion repeater.
Oh, okay. Interesting.
In order to get DMR, Fusion, or anything that requires digital ham voice modulation, you should get the DSD Plus software.
Okay. Well,
now the public release may not have everything compared to the fast lane. It's better to get the fast lane, which is worth the $10 for 1 year, or $25 for the rest of your life, and you'll be able to do a heck of a lot more with the fast lane than the public version.
Very cool. Very cool. So yeah, but thoroughly enjoying it. Hopefully, it's going to help the work that we're doing, and yeah, so cool. Definitely wanted to say greetings to Tom there in the chat. So nice to see you in the chat. Very, very excellent. So yeah, I'm hoping that Carolina Sky will drop in, because I'm going to I'm actually going to be doing some math here to show him what the actual separation between those two components of HW Virginis is, what the angular separation is. It's
you know what's also kind of like a bit crazy, Cosmic? It's that sunspot is still there. It's probably already done a spin around the sun already.
Yeah, you know, sometimes they do that. They, you know, if they're sort of in a stable situation, they'll hang around for you know, months. So yeah, I think I'm thinking that this one was already seen once, so I think it's gone around at least once, and it may, you know, continue. So I mean, it looks pretty stable. Haven't looked at it really today, but yeah, I think it's still.
I know.
there.
I know the
It's still big.
Solarflux has been doing a better job with that sunspot.
Interesting.
Good propagational conditions as well. Now, speaking of the sun, from what I heard, that the start of solar cycle 25 will be pretty much going to be around this year or next year.
Yeah, I think they're, you know, it's sort of right now, from what I understand, at least. I am no expert in this at all, but you know, there are certain signs that you know, things have changed, and we're going into a new cycle. And I think right now we're sort of in that you know, transitional phase. So yeah, I've heard everything from you know, it's going to start this summer to you know, they think it's going to start next year. So yeah, I mean.
And another thing I'll probably never mention about it, but last weekend's ISS SSTB Endeavor was a total complete bust. for pretty much the hams and the listeners and stuff.
Right. So is there any explanation as to why? Was it a transmission problem?
They said they're going to fix the modulation. They're going to fix the modulation.
Okay.
Never happened.
Yeah, okay.
So well, you can get the carrier, but you're going to fight with the receiver app or your receiver to make sure you get a good, decent decode.
Right, okay. Yeah,
otherwise, what's the point?
Right. Well, yeah, it sort of sounds, like it's probably on their end, and those folks are busy up there, right? I mean, they have to spend 2 or 3 hours every single day exercising, and then they have to actually work, right? They have to run all these experiments. So, I mean, I can't imagine how crazy it is up there. But
yeah.
I would think, I mean, this is just me, but I would think that kind of a thing is pretty low in terms of priority. So, hopefully it'll get fixed, right? I mean, it's probably, likely, to be some kind of a problem, that can be easily fixed. So yeah. Hey there, Chuck. Nice to see you in the chat.
Hey, what's up, Chuck?
As well. Great. So glad everybody comes in here every single day. I like it. I like it a lot. So yeah, I was looking at some TESS data today, and I actually posted a couple of pictures over on my Discord channel and challenged you to see if you could see things in there. But what I thought I would do here right at the beginning is sort of go through those pictures and show you what we're working with in terms of comparing TESS data to some other data. And in this case, what I've done.
Now, have you downloaded everything from TESS within that latest release?
No, absolutely not. That is
no. Well, let me tell you something. If you would, oh my gosh, I told you, what would you prefer, data overload or cuteness overload?
Oh well, I think I'll give you the same answer, and that is I want both.
Then why don't you just get all the data from that release, and we'll just look at it from day to day?
Well, I have to have a better reason than just having it. I've got to have a reason, to look at it. And all that. So if I've got a specific project involved, then I'll definitely go and grab it. Like today, I definitely wanted to see how test data images compare to some ground-based data, just to see what the differences are, and the differences are pretty striking. So let's go over and take a look at those. I'm going to share my screen here, and we will get into it. I'm going to hide that. I'm going to go over here, and I've already got these loaded up. So this is a sort of a typical TESS star field, and each pixel is about 22 arc seconds in size. So, relatively large pixels, actually. So here's a field, and you can see the individual stars here and all that. Here is pretty much And the alignment isn't exactly right, but here is pretty much exactly the same field of view with an image taken from the digital sky survey. So I hope you can see that okay. Here's a nice little barred spiral galaxy right here. You see that? This is NGC 1096, I believe. All right, so here's this nice barred spiral here. So this is an image that was taken, oh, I don't know, I think a couple of decades ago at least, maybe a few decades ago, from the ground. And this is what you get. Now, believe it or not, and I'm going to show you all this, so fear not. Believe it or not, this field of view from TESS is exactly the same field of view. There's a little bit of rotation and all that, but we're going to go through this. So what we have to do is we have to compare the star patterns. So you can sort of, what I do to do that is just sort of look at the brighter stars first. So I'm sort of seeing, like here's a bright one, and then there's a couple of bright ones here, and there's a bright one here, and a bright one here. It sort of makes this, sort of three-armed pattern here, right? 1, 2, 3, like that. You see? So let's try to find that pattern over on the Digital Sky survey. Believe it or not, it is actually here, and I have to remind myself a little bit too. Maybe, oh, okay, yeah, that's not exactly going to work. Let's, yeah, this star actually isn't in that field of view. So let's just look at these guys here. It sort of makes a right angle, right? It goes over here, and then a right angle up to here, like that. Okay. Now let's see if we can see it here. So, and I'm going to start marking things as well. So let's mark this as number 1, star number 1. Let me do that a different way. Let's go up here. Let's mark this as number 1, like that, and I'll just sort of move him into place. Oh, not that one, this one. There we go. So let's make that star number 1. And you can see it's a bright star, and there's a little faint star next to it. Well, believe it or not, that star number 1 there, and let's see, let's get rid of that, is this star right here, this bright one, but the faint one next to it. Believe it or not, that is star number 1 over on this guy. So I'm going to mark him like that. Oh, grab the wrong one again. So this star here is exactly the same as that star right there. And you see how these two stars, they sort of point to this other bright one over here. So let's make that star number 2. Do that, star number 2 right there. And we'll move him sort of into place. And then we'll do that. So do you see how these two point all right, to star number 2. So there's that guy right there. So let's mark him as star number 2, like that. Okay. So now let's go back up here, and you'll see that star number 1, star number 2, sort of kind of point up to this one. You know, there's a little bit of a turn here, right? So it's not exactly a straight line. And this looks extended. This might be some kind of a double of some sort too. So let's just make this star number 3. Oh, put that in the wrong place. Go up here, do that. So let's make that star number 3 right there. And so 1, 2, and you see the distance between 1 and 2 is about, you know, would be that far. So it's a little bit more, you know, this distance here is a little bit more than these two. So now let's take a look over here, and you can see 1, 2, 3. And look at that, it's a double for sure. So let's mark him. I'm putting a gender on this. I don't mean to do that, but so there's 1, 2, and 3 here. And see how it sort of bends this way, and this one is sort of bending that away. So you can see there's a things have flipped a little bit here, and yeah, I'm not exactly sure. This, I'm pretty sure I'm safe to say that this image, north is up and east is to the left. Okay, in the TESS image, that is definitely not the case. So things are rotated around and moved around because their coordinate system is different. They're basing everything off of the ecliptic plane, whereas this guy is based on the equatorial plane. So yeah, things are rotated around and flipped and all that, right? So let's actually try to see if we can see this guy over here too, right? So this is going to be number 4. Let's see if we can. I'm going to mark this one as number 4. Okay, and we'll sort of move him up into place. So if you take 1, 2, and 3, 4 is going to be, well, it's not exactly at right angles. It's, you know, some larger angle here, or maybe about 110 degrees or so, right? You can sort of make a line here and then a line here. But the distance between 1 and 4 is almost exactly the same as the distance between 1 and 3. So now let's look over on TESS and see if we can see that as well. And so here, let me get these guys up here. So here's 1, 2, 3. It's got to be that one, right? There's a bright one, and then a fainter one that sort of points to number 1 over here. So let's see. Yeah, see how that one points to number 1. So yeah, this guy's got to be number 4, right? Oh, let me do that. Let's go here. So that is going to be number 4, right there. Okay, so hopefully now you sort of have your bearings in terms of all of this. All right, so here's 1, 2, 3, and 4, like that. And the galaxy is, you can sort of make a nice little triangle here with 1 and 4 and the galaxy here. You see that? It's a nice triangle here. Okay.
Or make your own dip, or one of the two.
Whatever. So if we go over to TESS, we can sort of see that, oh, look at that. Right where the galaxy is over here, well, on the other one, there's a faint little smudgy thing. Doesn't, you know, is that a star? Is that a galaxy? With TESS, it's really, really hard to tell because the pixels are so big. We're talking about 22 arc seconds pixels. So, you know, the pixels are really, really, really big. And so a relatively small galaxy like that is only going to show up on a couple of pixels. And indeed it does. Right there. So you can sort of see, you know, if you use your imagination a little bit, there's some faint things coming off of here this away.
Now, is it possible to zoom that in to confirm, or you can't just do that?
Well, you certainly can, but you're not going to gain anything. It's still going to be a fuzz. There it is. Because the pixels are what they are. So you know, you're really not going to gain much at all. But as you can see, you know, there's some trailing stars here, and if you look in the digital sky survey image, you can sort of see that there are some trailing stars over here too. So this is an image from the ground looking through the atmosphere, and it's relatively old, right? I mean, it's probably, I think this is at least 30 years old or so. And in terms of resolution, in terms of being able to see details, right, this image is infinitely better than TESS. Yet TESS is a modern telescope in space, right? So it doesn't have to look through any atmosphere. It doesn't have to, you know, nothing. But you know, the TESS image is much worse in terms of resolution. Well, TESS wasn't made to be able to resolve things really well. What TESS was made for was to very accurately and precisely measure the brightness of all of these stars.
Welcome, Jim.
Hey there, Jim. Nice to see you. Hey, Jim, I've got a treat for you tonight, so hang in there. We're just doing a comparison now between TESS images and some old digital sky survey pictures. And we're focusing in, you know, sort of on this galaxy, but you know, we've also identified a few of the stars in the field too. And I'm just I'm pointing out, you know, the galaxy here, right, is nice and resolved, right? In fact, this, we can sort of zoom in here and see it. It's, you know, definitely a beautiful barred spiral. This is NGC 10096. It's way down in the south, you know, so we can't see this up in the north, but you know, it's a pretty galaxy, right? And um, um, just comparing that to the same field of view as TESS, and there it is, right there. Can't really tell it's a galaxy at all. It's sort of, you know, I mean, if you use your imagination and, you know, zooming in a little bit, you know, this, yeah, you know, I can't really tell, you know, that's a galaxy. That's, you know, if I didn't know that it was, I wouldn't be able to tell that. The only thing that is really telling, kind of, sorta, is you see how most of the stars have most of their light on like 1 pixel. And I'll sort of scan around here a little bit. That's overexposed, but see how, you know, the brightest thing, there's a little bit of a spread, but most of the stars, most of their light falls onto, you know, 1 pixel. And in the case of this galaxy, maybe if you use your imagination a little bit, you can tell that maybe it's a little more spread out. But, you know, if I were given this field of view and asked, you know, to identify, you know, the galaxies in this thing, I would say I don't think there's any in there at all. So, but it just so happens that there is. But yeah, you know, this is just a comparison, you know, between that. So see, but TESS doesn't really care about being able to resolve these things. What they care about more than anything else is just measuring the light that is coming from them. And so they don't really care about resolution all that much. The other great advantage that TESS has, of course, is that TESS can sit there and watch these stars change in brightness over long periods of time. They can stare at the same field of view for, you know, like a month at a time, and that is a great advantage that, you know, ground-based telescopes don't have. Right? You only have a couple hours, a few hours every single day to observe these things, and then you have to wait, and you have to contend with clouds, and, you know, all of that, right? But with TESS, you can very accurately measure the brightness of these stars, and you can watch them continuously for long periods of time. So I think that is absolutely fantastic. The next best thing would be to have some kind of large, very large telescope sitting in space that can also observe for long periods of time. And the best way to do that is to actually put a telescope on the moon. So you know, I'm a huge advocate for putting such an instrument on the moon. And you know, with a large telescope, you would have great resolution, and you'd have great photometric measurements, and you'd be able to observe objects, you know, continuously for weeks at a time. So I'm just a huge advocate of putting a telescope on the moon. If anybody wants to work with me on that, I'm trying to pursue that. So yeah, let me know, and we'll get working on that a little bit more. So yeah, I just wanted to do a comparison, between sort of your normal things, how they would look from the ground here, and compare those to TESS, which is, of course, a modern, currently working telescope going around the Earth, but in a very unusual orbit. And I forget exactly how this goes. I think TESS orbits the Earth, I think, once every 2 months, or maybe it's the other way around. It may go around the Earth twice a month. I have to look into that a little bit. But fact of the matter is that it's a completely different instrument than what this is. Just used to measure the light from all these stars, or at least a selection of stars. So I just thought that was extremely interesting, doing a comparison here in between the two, and seeing that depending on what you're looking for, you can extract some pretty amazing data. So anyway, so there's that. So what I wanted to do for Jim, and I'll come back over here for a moment, at least. I'll stop sharing. So Carolina Sky Astronomy was asking about being able to see being able to use his telescope, or some telescope, to observe the two components of the binary star HW Virginis. And so I sort of I mentioned at the time that he most likely would not be able to see that. Well, I'm going to present you with the math tonight. I'll show you some numbers, and we'll actually work out the calculation and determine, calculate at least, the angular separation between the two components of this binary system, and you will rapidly see that the separation between these stars is extremely small. So I haven't done the calculation yet. We're going to do it together here. So let me get you all set up here. I'm going to get out of GIMP, which was the display thing that I was using to show you the star field, and I'm going to start up another program to allow me to make some really bad drawings. So I am definitely not all that great at drawing stuff, but you'll be able to keep up, no problem. Let's see, what am I looking for? That's what I'm looking for. So as soon as this is loaded up, I will share my screen again. Yeah, I think I can go with that. So let's let me do that. Just want to make sure that I've got you all set up here, so I don't mess you up too bad. Okay, here we go. So I'm going to share my screen. Share. And I'm going to hide that. And we're going to come over to here. Okay, so I'm going to draw a couple of things. First thing I'm going to draw, and this is the only math I'm going to show you, is that there's a relationship between the distance. Well, I'm just going to do this. Let's draw, and this is going to be really, really rough, so, you know, forgive me. But I'm going to draw, oh, let's make that a little thicker. How do I don't remember how to use. I don't remember how to use this thing. Pencil.
Now you know it's been a long time since I used paint.
Yeah. Okay. I'm just going to do this really, really rough. Okay. So here's this, and here's that, and then I'm going to draw. I'm going to try to draw a line here. So this is really bad, but you'll just have to put up with things here a little bit. So let's call this the. I'll make it maybe green here. Let's call this the distance from us to the binary star, right? So this is the distance, okay? And then, and actually, you know, let's just call that X. Doesn't matter what it's called. Let's just call it X. And let's call this line the distance between star A and star B. Okay, so and we can call that Y. We like, and let's do. Oh, that changed that color. That's all right. So let's call this star A and this star B here. Okay. So these are the two stars, and this is the distance between them. This angle right here, which is extremely poorly drawn, but this angle right here, let's call that T for theta. Okay. So there's a relationship here that I'm just going to type out. The tangent of theta is equal to y divided by x. Okay, so if we want to, well, and what we ultimately want to find is what is the value of theta? What is the angular separation between A and B in terms of angles? So to solve for t, what you have to do is you have to take the inverse tangent of both sides of this equation. And when you do that, you get that t equals the inverse tangent. How am I going to do that? I can just go, I'll just go inverse tangent of y divided by x. Okay? And that'll give us this angle. And that's what we want. That's actually the angular separation between those two stars. So now, let's work out all these things. We need a value for y and a value for x. And those, of course, have to be exactly the same units. So, you know, be it light years or kilometers or meters or whatever it is, y and x have to be in the same units. So I've looked this up. The separation between A and B, okay, so I'm just going to do separation of A versus B is 0.874 solar radii. going to have to look that up. And the distance between us and this system, which is going to be x. Now, actually, this is y, right? The distance here is, excuse you, is, at least according to the literature, is 172.497 parsecs. And we can work out what the number of light years there is, because there's 3.26 light years in a parsec. So 172.497 times 3.26. Of course, I've grabbed my handy-dandy little calculator here. Let's see, that works out to, shoot, my poor calculator is 562.34 light years. Okay, so I think what we should probably do, let's convert all of these numbers into kilometers. Okay, I'm sort of randomly choosing that unit. You can choose light years, you can choose meters, doesn't matter what it is, as long as they're the same. Okay, so let's look up how many kilometers are in one light year. So 1 light year is going to be a certain number of kilometers. Let's go over to Google and find out what that is. Come on. Taking its time. Oh, I loaded 2 of them. The old potato is running pretty slow here. So we're going to go over here.
My last one before my new one was an old potato as well. Sometimes you end up want to kill one of the tabs on Google Chrome. You end up killing them all.
Yeah. Okay, so one light year. Let's see if we can. Here we go. So one light year is that many meters. We want kilometers. We can just divide that by 1,000, and we'll be good there. So let's go back over here, and we'll sort of plug that in. Can I? Ooh, I don't know if I can or not. Find out. There we go. But that's in meters, so let's change this to 0.8, like that. So that is going to be kilometers. Okay. So we have to multiply that by 562.43 in order to get the number of kilometers between us and these guys. Now, we're starting to deal with some big numbers here, but I think we can handle all that, right? So 946,073,04. I don't think my calculator is not going to handle that well. So let's see if I can.
I never handle with those types of numbers on a regular calculator app and stuff.
That's all right. We can deal with it here. No problem. No problem. We'll just go over here and we'll grab one of these and we'll use one of these guys. So 0.8 times, what was it? 562.43 light years. 562.43. Bam. So there's that. Bam. So there's that many kilometers between us and those 2 stars. So, there's definitely a few there. It would take a while. That's pretty far, actually. 500 light years away. That's you know, I mean, that's pretty far in terms of stars. So that means that X is going to equal that big number. Okay. So let's do exactly the same thing for Y. So we know that Y is 0.874 solar radii. So we need to know what the radius of our sun is in kilometers. So let's go find that. Let's go over here. Be able to type in the sun. And let's get a radius. Let's get a radius in kilometers. So the equatorial radius, that is good enough, is I don't know why there's a difference here. It's really, really small, so let's just grab that one. And it's already in kilometers, so we're not going to have to convert that. That's nice. Okay, so Y is equal to, whoop, that many kilometers. Okay, so now what we have to do is we have to take Y and divide it by X, and then take the inverse tangent of that number. Now, how am I going to do this? I think how I'm going to do it, I'm going to go back to my handy-dandy calculator here. And what I'm going to do is I'm going to take 696, 342, and then I'm going to divide it by, I'm going to count the number of decimal places here. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's check that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's 15 decimal places. So let's take 696, 342 and divide that by 5.320998 times 10 to the 15th. Right? And we get a very, very small number. Whoop, I think I did that wrong. Let's try that again. 696, 342 divided by 5.320998 exponent 15. So x divided by y, or I'm sorry, y divided by x is approximately 1.308668 times 10 to the negative 10th. Okay? Wow. I just noticed something that just happened. Here, I'm going to, and this is actually cause for a celebration. Let me show you what just happened to my handy dandy old calculator. Look at that. I'm seeing all the digits now. Wow. So that just happened. That's great. It's a miracle on Astronomy Daily Live. You've seen it live. Yeah. That decimal place, the fourth one, this one, was was out, and it has just now reappeared. Wow. Well, I like it. Back in business. Yes. Okay.
Well, looks like to me you don't need to suck up like I don't know how much all those scientific calculators are today.
That's right. That's right. Okay, so now I'm going to share my screen again because I forgot to do that. I like it. I'm back in business. All right, I'm going to share my screen again. I love it. Okay. So now what we have to do is we have to take this very, very small number and take the inverse tangent of that. And that will give us this angle t or theta, right? So I'm going to do an inverse tangent, and let's see if I can boost this up a little bit. Okay, so hold on just one sec here. Shoot, I need to do that all over again. 1.308668 exponent tan negative. We'll take the inverse tangent of that. Oh, shoot. Hold on. Inverse tangent 1.308668 exponent tan negative. Let's get this into, okay, so that number is, so that means that t is equal to about 7.498 times 10 to the negative 9th degrees. Right, so 7 billionths of a degree. So let's convert that to arc seconds. Okay, I'll come over here. So there are 3,600 arc seconds in 1 degree. So we can multiply that small number by 3,600, and we get. Did I do that the wrong way? I did. 600. 7.498 exponent 9 negative multiplied by 3,600. And we get going the wrong way here. So we get, let's divide that by 10. So we get 2, so T can also equal 2.699, 1, 2, 3, 4, 5, 6, right, times 10 to the minus 6 arc seconds, right? Which is, that's about, right, T, therefore, is about 3 micro arc seconds. So that, Jim, is the separation between those two components as we would see it from here. 3 micro arc seconds, 3 millionths of an arc second. So, yeah, like I was saying, never say never, but it is extremely unlikely that we will ever be able to separate those two stars with any kind of telescope here from Earth at all. The interesting thing is that if we were a planet, right, one one um, one astronomical unit away from this binary system, they would actually be about one solar radius separating them, or about 15 arc minutes in separation. So we'd be able to see those two stars from the distance that we are to the sun, and that would look very, very cool. That would look very, very cool. But yeah, that's an extremely small angle, and that's exactly what I expected. So yeah, it's a little bit of math. You can figure all that out. It's easy and fun, and of course, it's all based on this relationship between this angle and these two sides. Yeah, that's how that is worked out. And yeah, so that's extremely small. We are never going to see that from a telescope here. Never. That's just way too small. But we can look at the light curve and know for sure that there are at least two components, and we can use models to also create light curves that very, very closely match the light curves we observe. And what that means is that the parameters that go to making those models are probably correct, and the parameters are like distance between the two stars, the relative masses, the temperatures, the brightnesses, all the orbit parameters, and so yeah, we can make a pretty good guess as to what these two stars are without ever actually seeing them, which is really amazing. But the models are usually pretty good, because there's a lot of parameters. Oftentimes, the combination of those things give you the wrong answers. So you can never be absolutely sure, but I think the confidence can get pretty high, and so yeah, it's extremely cool that we can do this kind of stuff without actually being able to see the individual components. I think it's extremely cool. So yeah, I just wanted to run through that math with you a little bit. The science of astronomy is there's a lot of math,
Now, you want to know something about my phone that's just strange?
What's that?
They didn't put a calculator wrap.
A what?
No, I don't have a calculator wrap.
What?
I know.
Well,
why the crap did you have a phone and you're not going to put a calculator wrap?
You gotta get one of these, dude.
So I'm looking through the list of scientific calculator apps right now.
Yeah.
And you got the calculator, and you got the Clever Crack, Calculator Pro, Hyper Scientific, High EDU Scientific. You got the free version of the Scientific Calculator by RealMax, Real Crack by Quartrek. They come up with so many of these calculator apps, I can't even tell which one's going to be the best bet.
Yeah, I don't know either. Mine actually, mine came with an app. I've got a Galaxy X S7 here that I'm going to start up, and I will show you the app here. Um, I learned that if you turn it this way, sorry about the bright light there. That's kind of cool looking. If you turn it,
I don't even see it.
Yeah, I'll get this running here, and then I'll show you the app that I've got. And I think it's, like I said, I think this came with the phone, if I remember right. So if you turn it this way, you just get your basic thing. But if you turn it this way, it actually turns into sort of a scientific calculator, right? I mean, it's got, all the, a little bit more of the functionality there. But like I said, I advocate everyone getting just a regular old nice scientific calculator, and have it at hand, within reach at all times. And I think it's absolutely fabulous that this thing is working again. It's been months that I was starting to really be like, man, I can't really use this thing anymore because I can't tell what that fourth digit is. But it's back. It's back. It's amazing. What do you think of that, buddy?
Yeah. I have just recently downloaded the Hyper Scientific Calculator.
That sounds good.
And, well, if I could dismiss the YouTube video for now, and this is what it looks like.
Oh, there you go. Okay. So it looks like an HP.
Yeah, something like that.
I've got a dirty HP, but there it is. What do you think of this HP? Yeah? You like that? I'm glad you like it. Yeah, I still have to get batteries for this guy, but wow, I'm absolutely amazed. I have had this calculator since about, and I want to say like 1995, 1994. I forget exactly. And the one that this replaced, I had for about 15 years or so before that. But yeah, this thing has been going and going and going. You can see that many of the numbers,
some of the buttons, some of the number labels are missing.
Are completely rubbed off, right? Because of use. And yeah, it's absolutely amazing. But yeah, it's solar powered, so I've never had to replace the battery in here. I don't know if you're supposed to or anything. I never have. It comes in a little protective case. This calculator is never closed like this because there's just absolutely no point. I use it all the time, so I've always got it open like that, and it's always within arm's reach, and it's working again. It's unbelievable. So yeah, you saw it here. So yeah, I think that is pretty awesome. And speaking of awesome, I think it's about time to get on out of here. So I'm gonna check the chat one more time, really quick. And yeah, if I would really like to put a telescope on the moon. Something relatively large, half meter, something pretty sizable. Um, uh, the Chinese currently have I believe it's I think it's a 7 centimeter telescope. They're now, and that's actually been running for about 4 years or so. There's another group.
Jim, you're not on Discord. If not, I'm gonna go ahead and put the link to us to Cosmic's Discord just for the heck of it.
Oh yeah, yeah. Jim, if you're so inclined, jump over to the Discord server and get on there. It's not incredibly active, but it's moderately active. I try to post there, several times a day and stuff. So yeah. And there's another group that's actually going to be putting a telescope. They're going to be going on the Moon Express mission, which is going to the South Pole of the Moon, and they're going to be putting a telescope there too. Again, really small. I'm thinking, that I want to do something a little bigger. So not only do we have really great light gathering capability, but the resolution is really great. And on the moon, you can do exactly the same thing as TESS.
Jim, are you on Twitter? Because if you're on Twitter, you can give me your tag, and I'll pretty much go ahead and follow you and stuff.
Absolutely, Jim. Do it. And Jim, I partially agree with you, and I partially don't. I think we have this idea that we need, the biggest and the fastest and the and the most expensive and all that, and that hasn't been my experience. I always go back to the bowling ball, and when you're bowling, right? Where, what does your score depend on? Does it depend on the bowling ball, or does it depend on you as a bowler? Okay. Well, I argue that until you get to a really high level, right, the 99th percentile, that bowling ball makes no difference whatsoever at all to your score. It has to do with the bowler. It has to do with you, and that's why this scope here, right, that is my bowling ball, and right now, I am definitely not operating at the 99th percentile. I might be operating at the 50th percentile, right? So the bowling ball doesn't really matter. What matters is how well I bowl. How good is my aim? How good is my technique? All of that, right? And the bowling ball doesn't matter much as long as it's round, as long as I'm able to put my fingers in it right. I'll score pretty darn high. Now, if I want to be a professional bowler and compete and bowl really high scores, then that's when the ball starts to matter a little bit. But for the most part, even professionals don't need the the perfect telescope or camera and all of that. It's more to do with your technique, getting the data, processing it, all of that. That should be the focus. Don't worry about the bowling ball too much. So yeah, absolutely, absolutely. So yeah, Jim, you just confirmed exactly what I just said. So it's the technique. Um, you know, for the most part, right? That last highest percentile, that's where the equipment starts to matter um, 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 just a little bit, and it depends on um, you know what you're after, right? With this scope, I'm not going to be able to see 18th magnitude asteroids. Not a chance, right? Not a chance at all, because my bucket isn't large enough. I just need a larger bucket. But so I don't score 250, 260, 280. I'll score 200, which at this point is good enough. All right, I think I'm going to get out of here for now. So thanks everybody again for coming in. A little bit of math, as I said, science of astronomy is heavy, heavy, heavy into the math, heavy, heavy. But math is just a tool, just like anything, right? Here's a tool too, right? Here's a tool. Here's a tool, right? It's just a tool. Don't be intimidated by the tool, right? Learn how to use it, right? You gotta take this part off first, right? You gotta do that, and you've got to put that on there, right? And then you've got to know how to hold it, right? So you can't hold it like this, because it's not going to write very well, right? You've got to hold it.
You ever seen
like that.
America's Funniest Videos when, I think, the older senior people were the way how the elderly people were holding the mic? They were holding it more like this, more like if you was on a telephone or something, and it was and it's like, dude,
Yeah.
you've never seen a microphone or never used it before?
Right. Well, that's exactly how I feel about mathematics, right? So don't be intimidated by the math. It's a tool, just like anything else. And it can be an extremely powerful tool. It can show you really, really interesting relationships, and mathematics can allow you to calculate some pretty interesting things, like what we just did. So, all right, everybody. Yes, for the third time, I'm going to say I'm going to get out of here, and I'm going to get out of here for sure. So take care, everybody. Make sure to subscribe if you haven't already. Thumbs up if you so desire. Make some comments and share this around. Share this with friends. I definitely want to extend this passion of mine to as many as I possibly can, because that makes me feel better. I will be here once again tomorrow, 2 hours UTC. Oh, by the way, the live stream for the 19th is going to be canceled. I've got some things going on, and like I always say, I don't like to rush. So I've got some stuff going on that evening, which is actually the evening of the 18th here. I think I'd probably be back in time, but I I hate to rush. I hate to have to hurry. So I'm just going to cancel the live stream for the 19th. Yeah, that's just how it is.
Do what you gotta do. And Jim, you need to either get on the Discord or get yourself a Twitter.
Yeah, just let us know, Jim, one way or another, because yeah, you know, it's always fun, you know, to communicate in the myriad of ways that we can. So yeah. However you want to do that.
And did you know if Facebook shuts down, if Facebook is down for some reason, you know that Twitter's really gonna help you get you straight back up.
Yeah, absolutely. Okay, everybody, I'm gonna get out of here. Peace, cheers, and all that. I will see you on the spin a little less than 23 hours from now. All right, everybody, take care. Bye.
Long and prosper.